inside this parentheses fit into the bottom or the top function? Well, if I want to find f of 2, 2 is greater than 0. So the bottom function accounts for 2 being greater than 0. So f of 2 in this case is 2. Remember, if there's no x value, there's no multiplying. Those are simply horizontal lines. So if I graph this, it would be like 2 horizontal lines in opposite directions. Again, this is asking for f of -4. So again, I have to go, okay, here's f. -4 is not greater than 0, so it's not the bottom function. -4 is less than or equal to 0, so f of -4 is 3. F of 0. Well, 0 is tricky because 0 occurs on our breaking point. It occurs at the transition point where the domain changes. So now I have to look even more specifically at the inequalities, and I have to say, okay, which one includes 0? The top or the bottom? So we look for the inequality symbol that has the equal part, which is the top one. So that tells me f of 0 is 3. One-half. Is 1/2 bigger than 0 or smaller than 0? Well, 1/2 is larger than 0, so x is bigger than 0 for the bottom equation. So again, if you put 1/2 in here, 1/2 is greater than 0. So f of 1/2 is 2. Now, the middle row is all talking about the function g. So all of these points are all going to fit into the middle piecewise. So now we kind of ignore f over here, and now I go, all right, g of 7. So I want to say, is 7 less than or equal to 3? No. Is 7 greater than 3? Yes. So I plug 7 in to the bottom equation. So that means g of 7 is kind of like saying 2 times 7 minus 1. So 2 times 7 is 14. 14 minus 1 is 13. So g of 7 is 13. How about 0? Is 0 less than or equal to 3? Yeah. So you plug 0 in for x in the top equation. So you get 0 plus 5, or you get that g of 0 is 5. What we're doing, plugging in these values into the piecewise, is what you were doing yesterday when you were graphing them. You were figuring out what value of x makes this inequality true and says, okay, you can plug it into that expression. So again, this is a piecewise function. Its breaking point for g of x is at 3, and the expressions that make it up are x plus 5 and 2x minus 1. So again, -1 is going to be less than 3, so we plug it in to the top function. So you get -1 plus 5, which is 4. 3. 3's on that breaking point again, so I have to figure out which breaking point includes 3. Well, 3 is included in the top function, so we plug 3 into the top, and you get 8. Are there any questions on plugging in to the piecewise functions? So again, when we plug into these functions, it's the same as when you plug in to make your table of values. So all of these points that they picked might have been good points to pick to plug in to this function to get yourself a graph. So you kind of always want to look at that breaking point, and you want to look at points to the left and to the right of those breaking points. So in example 1 now, we want to graph this piecewise function again. And this piecewise function is kind of like last night's. We have 3 breaking points. So I have to look at those breaking points, and I have to say, okay, what's to the left of them? What's to the right of them? What numbers do I want to plug in where? So if I treat the top function in red, I want to find values for x that are going to be true to this inequality. Well, x has to be less than or equal to 0. So that means I need negative numbers. So maybe -2, -1. But remember, you always want to actually look at this number. So I look at 0, and 0's included. So that means now that on my graph, this point at 0 is going to be a closed dot. So plug in my values. -2 plus 3 is 1. -1 plus 3 is 2. 0 plus 3 is 3. Remember, these are ordered pairs. You graph them like ordered pairs. So I graph -2 on x, +1 on y. -1 on x, +2 on y. 0 on x, 3 on y. Connecting my points, there is the left piece of my function. The middle piece is nice. Don't keep getting messed up by the fact that if it's just a single number for y, it's a straight line. So if this is a 3, my y in my table never changes. No matter what 3 points I plug in for x, I know y. Y doesn't change. What I have to be cautious of, though, is at the breaking point 0, this is an open circle. Say I plugged in 1, and I plug in 2. At 2, which is my second breaking point for the middle piece, it is closed because x is less than or equal to 2. So if you graphed this on a number line, that 0, x, and 2, if I asked you just to put that on a number line, you would have drawn your number line and you'd have put -1, 0, 1, 2, 3. And you just said, okay, open circle at 0, closed circle at 2, and I shaded everything in between and nothing else. Well, that's kind of like what you're doing on these graphs. You're going, I don't care about what happens to the left of 0. I don't care about what's to the right of 2. I only care about what's happening from 0 to 2. So from 0 to 2, this graph is at 3. And what happened this time? My graph's actually connected. So that's okay. You have an open on a closed, so it just remains closed. Okay, and finally, let's look at the bottom equation. So I have 2x minus 1 for x greater than 2. So again, I want to start with 2, go to 3, go to 4. This is open because 2 is not included. 2 times 2 is 4. 4 minus 1 is 3. 2 times 3 is 6. 6 minus 1 is 5. 2 times 4 is 8. 8 minus 1 is 7. So go to 2, 3. Oh man, they overlap again. That's okay. Then you have 3, 5, and 4, 7. If you talked about domain and range for this problem, does this include every x value in the entire world? Does my breaking points match up? Does 0 go to 0? And 2 goes to 2? So if all the breaking points match up, my domain becomes all reals. How about the range in this case? If this goes to infinity on y forever, this goes to negative infinity on y, what happened to the range on this problem? This is the first time we've had a range that does this. Does every value of y have a point? Yeah. So this is the first graph where all the y values are included also. Is this graph a function? Does this pass the horizontal line test? It does, because no point on x has a second point. So this is a function. It's not one-to-one because of this horizontal piece right here. You guys are in physics. This would be like a particle moving forward, stopping, moving forward. Okay, well, let's go down to the next graph. So go ahead, take a minute, and I want you to see if you can identify okay, 2 lines going in opposite directions, making my domain all reals again, because the jump points match up, and my range, well, my range is kind of goofy. It's y less than or equal to -6, and y greater than, but not equal to 1.